Hello 7th graders, your new video is for section 9.4, which deals with compound events. So a compound event just means that you have two or more events that you are considering at the same time, more than one thing happening. So if you say that the events are independent, you're saying that the occurrence of one event does not affect the probability of the occurrence of the other. So one event does not affect the other one, like spinning a spinner and flipping a coin. They have nothing to do with each other. If I spin a green section on a spinner and I flip a head, they're not affecting each other. They have nothing to do with each other. So if A and B are independent, which means they do not affect each other, the probability of getting an A and then a B, or the probability of event A and then event B, equals the probability of event A times the probability of event B, because you want two things to happen. So what is the probability of getting a head and then a tail when you flip two coins? So probability of getting a head the first time, if I can get my pen to draw, is 1 out of 2. And the probability of getting a head the second time, again, is 1 out of 2. Let's just pretend that looks like a 1, because I don't know why it's looking like that. Then I just go ahead and multiply it. So I get a 1 in 4 chance that I'm going to get a head and then another head. And again, they have nothing to do with each other. They are independent. So it's going to be a 1 in 2 chance and a 1 in 2 chance. If I flip another one, it's another 1 in 2 chance, right? Because when you flip a coin, it's not affecting what you get next. So dependent events, the occurrence of one event affects the probability of the occurrence of the other one. So the first one does affect the second one now. So this has to do with the lab that we just did with the colored cubes that we put in the bags. So if I would have kept out one cube each time that I pulled out, then the probability of getting cubes the second time is going to be affected because there's less cubes in the bag, right? So that would be dependent if I would have kept some cubes out. So if event B depends on event A, then the probability of A happening and then B happening is the probability of the first event times the probability of the second event after A happens. And I'm going to do an example with you. So if I have 10 quarters, 8 nickels, and 5 dimes in a jar, what is the probability of picking a quarter and then a nickel without replacing the quarter? This is the key word, without replacing. That means I keep that coin out. I don't put it back in. That's going to affect what happens the second time. And I'll show you an example right now. So first of all, what is the probability of picking a quarter? So the probability of picking a quarter is, I have 10 quarters. I have 10 quarters out of 23 coins, right? So I have 10 chances out of 23. Okay, then it says I want to choose a nickel. Okay, well, I have 8 chances of choosing a nickel. Be careful on this part. This is what changes with the dependent ones. Are there still 23 coins in there? If I didn't replace the quarter, there's 22 coins in there. So it's going to change the total of what's in there. So I can reduce these, right? If I divide by 2, make it a little bit easier. So 40, and then 23 times 11 is 253. And that cannot be reduced, so that's your answer. Okay, so then let's look at a couple more examples, just like that one. So let's look at this same example, but now let's change it up a little bit. Let's say that I want probability of quarter and then quarter, and again, not replacing. Let's look at what happened. Okay, probability of quarter the first time is 10 out of 23, right? It should be a 3. and the probability of a quarter the second time. If I don't replace the first quarter, I now have 9 quarters, and I have 22 coins. Do you see how that's changing? Right? Now let's compare that to, let's say I want a quarter and then a quarter, but I do replace, right? So this computer is being crazy today. Okay, do you see the difference? Here I replaced it, here I did not, right? So what are my answers going to be? Here I'm going to get 45 over 253. And here I'm going to get 100 over 529. See the difference? This answer is a lot different than this answer, right? So you have to pay attention to the wording. Is it replaced or is it not replaced? Not replaced always means dependent. Okay, so make sure you keep those two things in mind when you come to class tomorrow. We'll talk more about it. Have a good night.